Several years ago, we built KV, our robot guinea pig, based on a CamJam kit and powered by a Raspberry Pi. Our first adventure into the world of coding, we got it to do some basic things, and designed a cardboard shell inspired by K9 from Doctor Who. But that's about as far as we got, and since then, KV has been gathering dust. But now, with the boys doing their GCSE in computer science, it seems the perfect time to revive the project and make a couple of videos along the way. And our timing couldn't be better, coinciding with a couple of useful articles in Hackspace magazine, reminding us what we did for the project and providing some useful code. So first, let's walk through the assembled prototype. We have our Raspberry Pi with our motor control hat, black and red cables going to the two yellow motors, and a battery pack to provide them with the power. The Raspberry Pi itself has a separate power supply mounted under the chassis. Just behind is the caster, which sadly has lost its ball bearing. Here you can also see the cable ties that hold on the yellow motors, with their chunky red wheels. We also have the various sensors, which I'm pretty sure we never got working. For the rebuild, I'm generally going to follow the same design, but I will be using a Raspberry Pi Zero instead of the original, and adding an on-off switch with this little shim that sits underneath the motor control hat. Other than that, the components will be pretty much the same, so one by one they can be removed from the chassis and stored away, ready for use. I've even got the original box to keep them in. Then I can loosen the terminal screws and remove the motor wires and those from the battery box and put those to one side for later too. Now, finally, we come to the construction of KV Mark II proper. Most of the rebuild is a case of improving construction techniques and materials, and I'm starting with the chassis base, for which I'm using some rigid plastic sheet instead of the plywood on the original. I'll be laminating this into a double thickness, which will give us the rigidity we require. So the first thing to do is to mark out two identical sheets and cut them to size with a razor saw. This will give us a nice clean edge. The plastic has protective film on both sides, so at this stage we don't need to worry too much about damaging the surface. The original design happened rather organically, trying out new ideas as we went along, and bits of it are quite crude. So with Mark II, we can iron those out at the beginning, starting with the angles at the front of the base plate for KV's face. This time they can be accurately marked and adjusted slightly for the optimum fit of the body shell over the components below, and then cut using the razor saw again. First for the bottom layer, and then for the top, marked up exactly the same, until we have the finished shape for both layers, which fit perfectly together. Now we come to why I've used transparent plastic, and another reason for the two layers, as I am going to spray paint the inside face of each of the layers, giving us a super shiny surface. So having peeled off the protective film on one side only, I can take them outside for spraying. For this I'm using a standard acrylic aerosol, building up the layers of paint gradually and evenly, but actually not worrying too much about some of those splotty bits, until we've got a really nice, even and solid black coat of paint. You'll see the outside has still got its protective film, and now we're going to sandwich the two layers with their painted sides stuck to one another with some permanent spray adhesive, being very careful to line them up perfectly, as you'll only get one shot at this, and once you're happy with the alignment, you can commit and press down firmly, making sure there are no gaps around the edges until you've got a perfect sandwich. Those edges can now be sanded using a multi-tool, progressing from a medium grade paper to something very fine to get a nice smooth edge. Work slowly and evenly and make sure everything stays straight and we don't lose any definition on the corners. And that's our chassis base, complete and ready for drilling for the components. But first I want to add the on-off switch to our Raspberry Pi, which will require a bit of soldering, and to make that easy as possible I'm brushing on some liquid flux to the header pins. This will mean that the solder flows smoothly and I can make a neat job of it. Adding the switch means I can keep the power supply plugged in all the time, powering down the Pi Zero and switching it back on again with the touch of a button. And having levelled off the shim with a couple of bits of cardboard, I can start to solder. With a bit of practice, my soldering is improving, and assisted by the liquid flux, and a brand new soldering tip, I'm managing to make a pretty neat job of it, which is important as the motor control hat is going to sit on those same pins. I'm not sure how many of the pins actually need to be soldered, and some are not required for the operation of the switch, but I'm doing them all anyway. It looks like I can also add an external button, which will be useful as that button on the corner is pretty fiddly, but that's a job very much for a later date. And for now, this part of the job is just about done, and I can remove those temporary spacers. And with the switch shim perfectly level, refit the motor control unit, referring to the original instructions just so we get it on the right pins, and then pushing down firmly. With that job out of the way, we can return our attention to the chassis, positioning the various components where we want them to go. Most will be on top of the board, but some, like the power bank for the Raspberry Pi, will go underneath, and we'll need to drill a hole for that wire to come through from the bottom to the top. That micro USB connector is quite chunky, but rather than drilling a large round hole, I've marked up the position for an oval slot, drilling 2 small pilot holes which will be enlarged later. And as that protective film is still in place, I can be pretty free and easy with my Sharpie, reminding myself which is the top and which is the bottom. Now, with a larger drill bit centered on the pilot holes, I can enlarge them for my slot. The first I'm drilling partially to establish its position, but the second I can drill right through in first go, before returning to complete the first one. Then, with the majority of my slot opened up by drilling alone, I can tidy up those inner edges with a needle file until I've got the hole the right size and shape for my connector to fit through, where it will eventually plug into the Raspberry Pi using that new switch. As with the prototype, I'm using a variety of methods to mount the components to the chassis base. The breadboard for the sensors at the front of the robot will be bolted into place, so I just need to drill some appropriate holes. The power pack for the Raspberry Pi will eventually be stuck on the completed base with sticky fixers, but for now I'm sticking it onto the protective film to get the position right, before marking up the locating holes for the Raspberry Pi, which will also be bolted to the base using standoffs to give a bit of clearance. One of the mounting holes is obscured by the on-off shim, but as the Pi Zero is so small, 3 standoffs will be more than adequate. And first I'm drilling the holes for the rear 2. Then, with the Raspberry Pi held in place with 2 of the bolts, I can more accurately drill for the third, and then put the Raspberry Pi to one side for later. Now we come to the motors. If there's one criticism of the CamJam kit, it's the lack of any mounting lugs on the body of the motor, and the reliance on sticky pads to hold them in place. But using cable tie straps on the prototype worked pretty well, and I'm doing much the same here. First off, I'm measuring and marking where the fronts of the motors are going to be. Then I'm going to need to mark for 2 holes for the straps to go through. For Mark 2, I'm moving the holes a little bit further forward, so the straps will go either side of the axle. And using a square, I'm just making sure that both sides are the same. And then drilling a pilot hole using a small drill bit, which is much easier to line up accurately. Again, I'll be enlarging these later, so my cable ties can thread through. On the prototype, the cable ties just wrapped around the edge of the board, but for Mark II, I thought I'd move the motors in a little bit from the edge, and I'm drilling a couple of slots for the cable ties to fit neatly along the edge of the board. The pilot holes are just inside the edge of the board, and when all of the holes are enlarged with a larger drill bit, the ones on the side will just break through the edge to form our slots, with our protective film still doing its job of keeping the surface pristine. And here you can see how our pilot hole keeps the drill on course, rather than skating off the edge, which it would do if we tried to do it in one go. And here's the completed drilling for the left-hand motor. We now need to repeat the whole process for the right-hand one. Again, starting with the pilot holes, which are then enlarged with the larger drill, both on the inboard side and at the edge. And that's our drilling complete. We've got holes for the Raspberry Pi, for the motor, and for the breadboard at the front. And with a final sand of the edges, with the finest grade paper, we can peel back that protective film, ready for the final assembly, just cleaning up any rough edges with a needle file. As always, before sticking anything down, I want to check the positions. And I've realised, because I've brought the motors in from the edge, the motor battery box doesn't quite fit anymore. So I'll need to remove the inside axle that's not being used with a razor saw. I've also decided that the yellow motors don't quite fit my aesthetic, so I'm going to spray them black, masking off the areas I don't want the spray, and particularly on the moving parts of the axle. And with both motors removed from the prototype, cleaned up and masked, I'm taking them outside for spraying, first with a coat of grey primer, and then black with a satin finish. While they're drying, I can sort out my battery box. This comes with a switch on the front, but I want to mount it on that side, so I can leave it open to change the batteries more easily, so I've decided to bypass the switch. The wiring cover can easily be removed by slicing off the tops of those pegs and prising off to reveal the wiring below. And it's a straightforward job to unsolder the black wire from the switch terminal and attaching it directly, rendering the switch inoperative. When the painted motors are dry and the masking tape all removed, I can start a chassis assembly in earnest, beginning with the motors. First of all, I'm trimming some double-sided sticky foam pads to the width of the motors and sticking them on the bottoms. And then, with the cable ties already threaded through the holes, I can peel off the backing sheet from the other side and carefully stick them into position. The sticky pads keep the motor in place, but it's the cable ties that really give the strength to the mount. And these can be pulled over the top of the motors and threaded through the end, pulling finger tight until you're happy with the position. And when you are, pulling really tight with a pair of pliers, being careful not to scratch our lovely shiny surface. Then repeat the whole process for motor number 2, and with the 2 motors lined up properly and the cable ties really tight, we can snip off those ends with a pair of scissors, just leaving about a centimetre. While the motors need the extra strength afforded by the cable ties, the sticky fixers will be more than enough for our battery box, and I'm sticking 4 of them onto the bottom. Then peeling back the backing sheet and moving into location, just hovering above the chassis base until you're completely happy with where it's going to go, and then you can push down. Flipping over the chassis, we're going to do very much the same thing with the Raspberry Pi power supply, but first I need to snip off a little bit more of those cable ties to make room. The slimline model I'm using is also fairly light, and 4 sticky fixers is going to be more than adequate to hold it on. And once the USB cable is threaded through our hole, we can line it up, adjusting the position, hovering above the baseboard, until we're happy that it is square and straight and central, before pressing firmly home. Now we can mount the brains of our robot, our Raspberry Pi Zero, and as everything is looking pretty nice so far, I've decided to go for a slightly less Heath Robinson solution, and I've ordered some proper standoff bolts, along with the other things I need, from Pi Moroni, where I got the on-off shim. And as well as a button for that, I've got myself a nice black breadboard and a ball caster to replace the one missing from the prototype. But first, those standoff bolts. I'll not be needing the extra risers, at least not for now. Just pushing the bolts through the bottom of the baseboard and screwing down the hexagonal standoff, tightening with a precision screwdriver. This I'll need to do for all 3 standoffs, remembering that the corner with the on-off shim won't have one. And when they're all attached to the base, I can bolt down the Raspberry Pi, again just using 3 of the small bolts, tightening as we go to produce a really professional finish. Likewise, replacing the red breadboard from the kit with a black one will help to enhance the aesthetic, and even though the new one has a nice piece of double-sided sticky foam on the bottom, I'm discarding that in favour of using the bolts as I planned with the red one, and all I need to do is push them through my pre-drilled holes and tighten the nuts on the underside. Those of you familiar with LEGO building instructions will know that the wheels always go on very near the end of the project, and you'll be pleased to know that that's where we're getting to now, at least in terms of the chassis. And with the big driving wheels pushed onto their axles, I can fit the ball caster for the back. I've chosen a smaller one than the original prototype, but that comes with a set of spacers, so it will be the same height. Although I do need all of them to get the chassis level, which I'm just checking with a ruler. I then need to work out the position on the baseboard itself, just measuring for the centre and marking the position of the holes with a gold pen that shows up really nicely on the black, and double checking the measurement from the back of the board. They can then be drilled, using an appropriate bit for the supplied bolts. And the bolts push through the caster, the two spacers, and the baseboard itself, and then the nuts tightened up on top of the board. Then a quick test to see that the caster rolls smoothly in all directions. Last of all, in terms of construction, we can refit the motor control hat, which I took off earlier to make fitting the Raspberry Pi easier, and then to wire it up, making sure we get the right wires to the right terminals. The ones from the battery box go to the middle pair on the motor control, and those either side to the motors. You'll soon find out if you get the polarity wrong, as one motor will go one way and the other the other. Then, having tightened up all of the terminal screws and made sure that the wires are installed correctly, we can go on to power up our Raspberry Pi and test the whole thing. Our power pack isn't fully charged yet, so I'm just plugging into the USB, and a quick press of the button on our shim starts up the Raspberry Pi exactly as it should, although it did take quite a lot longer than is shown here. As its name suggests, the on-off shim doesn't just help turning the Raspberry Pi on, but will shut it down safely too. But for this, we need to install a little bit of code, which we can get from the product page on the Pi Moroni website. It's that line of code in black, which we will need to type into the terminal on the Raspberry Pi. And after a couple of efforts, I finally got it right and installed the software. So now, rather than fiddling around with cables, just a touch of the button will turn the Raspberry Pi on and safely off again. Now to test our robot, and for this I'm literally copying in the code from Hackspace magazine into the Python window and running this short program. A second program can test the direction, and I'll include a link to the Hackspace site in the description below. So with our chassis complete and functioning as it should, that wraps up part 1 of the project. In part 2, I'll be looking at the body shell, so expect a bit of cardboard engineering and some more programming to get our robot to do ever more sophisticated things and use those sensors to avoid collisions. So if you want to know how it all turns out, don't forget to subscribe. And if you found it interesting, check out some of my other videos of other practical projects. And thanks for watching.